Well, welcome to the lesson for section 10.6 and not 10.6, 11.6. I don't know why I keep being stuck on chapter 10, but this section is covering quadratic functions and their graphs. Now, what's going to be important about the lessons in section 10.6 is that the same things you're going to do with these functions in 11.6 is what you're going to be doing in 11.7. So I'm not going to be showing working every single problem in section 11.7 from beginning to end. I will show some examples of what that will look like so that you'll be able to do them, but for example, in this section, we're going to be asked to do things like find the maximum minimum value, or to find a vertex or an axis of symmetry. You're going to be asked to do all those things in section 11.7, and the way they're done in section 11.7 is the same way that they're done in 11.6. So we'll ask that here too if that wasn't clear. But what will happen in this lesson is we will show you with simpler quadratic equations how this is done. So we're going to take a little bit of a different look at a different way of writing a quadratic equation from the form of it that is easier to graph because of the way they construct the information within the quadratic equation itself. We're going to begin this lesson with just some basic graphing techniques where we're given a quadratic function, we're then given a table, and then we are going to have to do some plotting of it. So let's go ahead and take a look. We'll start with question number 15. And the function they give us is f of x is equal to x squared. So this is like the basic equation here. Now, if you're more comfortable doing it, you can go ahead and rewrite this as y equals x squared. So you can label this graph if you want here as x, and you can either label this as f of x, or you can label it as y. Whatever you're comfortable with, I'm okay. But just so you know, on MyMathLab, you may see f of x in place of y, and the f of x just simply represents the function notation we've looked at before. So we're going to use this function, and we're going to go ahead and create a table. So we're going to put these tables down below here. So this is going to be x. This is going to be what x is equal to, and this is going to be x squared, and then that's going to produce our values of y here. So we're going to look at putting some points down here. In the beginning, for the first few problems here, we're going to go ahead and use some simple points, and I'll kind of go through for why I pick what and why I do it. And because this is a simple x squared, I'm going to pick points like -2, -1, 0, 1, and 2. So what I'm going to do is I'm going to replace each of these values of x here. I'm going to replace x with -2 here, x with -1 here, 0, 1, and 2. When I square these, this is going to give me my value of y for the equation here. So that's going to be 4. -1 squared will be 1. 0 squared will be 0. 1 squared will be 1. 2 squared will be 4. So what I want to do now is produce some points that I'm going to go ahead and put to graph paper. So my xy ordered pairs that I've got here are -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And I'm going to go ahead and put those points down, and we'll see what the graph of a quadratic equation looks like now. So here's my point, -2, 4, -1, 1, 0, 0, 1, 1, and then 2, 4. So one thing to keep in mind as you're doing this, if you don't have graph paper, I go to a simple site called mathbits.com. That's mathbits.com. And if you just type in mathbits and you do a search for graph paper there, it'll show you a site where you can type 4 of these per page, and you can produce very cheap graph paper that way that you can use for your homework assignment. So now that I have these 5 points, how do I graph this? Well, I'm going to draw a line coming down, going through the points. You're going to see that there's going to be no possible way of drawing a straight line through these. So, what are the characteristics for when we look for a graphed line? So, what do I want? So, a good line. When you graph a parabola, oh, by the way, this kind of shape here, in case you didn't know it, this shape is called a parabola. So what's going to make a line good? Okay. Should be a smooth curve. It's not going to be a straight line, straight line, straight line, straight line, and straight line going up. Should be a smooth curve. 2, you should go through all points. 3, it should have arrows on both ends. So, and we'll talk about more features of this later, because we're going to be looking at more characteristics of this. For now, all we want to do is just kind of practice what it takes to graph these lines. So that's question 15. We're going to show just a couple of more and see what these look like from here. So we just want to kind of take a look at the characteristics of these and graph these out. Online, you will have a graphing tool that will help you map these quite nicely. For the purpose of your homework, I would prefer to see these. I don't insist on them, though. I realize not everyone has a printer at home. Not everyone can produce graph paper. If you could buy graph paper, that would be great. But if you could draw these out by hand so I get a general characteristic of what these look like, that would be helpful. There will be other specific things that you will have to show graphically, which we'll include later. But for now, we're looking at are the basic characteristics of graphing a quadratic equation or graphing a parabola. Let's go ahead and take a look at the problem next let's go ahead and take a look at question 18. And we have for 18, f of x equals negative 3x squared. So you notice that in the first equation, we just have a positive x squared, and that when this is positive, this is going to open up. Well, let's see what happens when we have this negative 3x, and let's see how this impacts the values we get here. So again, I'm going to pick my values of x. I'm going to call this negative 3x squared, and I'll take a look at my values for y, and then I'll look at my points x, y that I generate from here in this column. So I'm just going to pick again negative 2, negative 1, 0, 1, and 2. So I'm going to take negative 3 blank squared, negative 3 blank squared, negative 3 blank squared, negative 3 blank squared, negative 3 blank squared. With all the different values of x, I'm going to put into here. Negative 2, negative 1, 0, 1, and 2. When I take negative 2 squared, I get 4. Then that'd be negative 3, that'd be negative 12. So we're going to be going down a little bit. Negative 1 squared will be 1. 1 times negative 3 will be negative 3. 0 squared is 0. 0 times 3 is 0. 1 squared is 1. 1 times negative 3 is negative 3. And then 2 squared is 4. 4 times negative 3 is negative 12. So that's going to give us the points negative 2, negative 12, negative 1, negative 3, 0, 0, 1, negative 3, and then 2, negative 12. Okay, and what you'll see here is that when we plot these points, we're going to be going a little, unfortunately it's going to kind of collide with the graph here, which I didn't intend, but we'll live with that for the moment. Oops, not here, here. Negative 1, negative 3. This will be 0, 0. This is 1, negative 3, and this will be 2, negative 12. So it's going to go something like this. Like so. I apologize for that conflict in the graph. So the graph of it itself, let's go ahead and see if we can draw that in here. So at least you get a good clean picture of it. If we have the point 2, negative 12, it's going to probably go down about here. 2, negative 12 will go down to about here. And we're going to try to make these lines smooth. We'll try to have it go through these points. So we have it like so, and we'll have this like so. So here's a parabola of this quadratic function or quadratic equation. What makes this a good graph? Smooth curves. Not perfect, but what can you do? I don't expect perfection, but it should look pretty precise. It does need to go through all the points, as this one does, so make sure you have your points clearly identified. And that should have the arrow at both ends, which this one does. So make sure the graph has those three characteristics. So one thing you should pay attention to, too, is that when you look at this parabola and you look at this parabola looks significantly more narrow than this one does here. If you use a graphing tool online, you can look to see how the values in front of the x squared term impact the shape of the parabola. And usually when this is larger than 1, it has the effect of narrowing the parabola. Another different characteristic about the parabolas in the first and second graph here too is that this parabola is upwards while this parabola is going downward. So when you notice if you have a positive 1, this is positive, it's kind of like a smile. Where if you have a negative in front of the x squared term, this is more like a frown. That is just a kind of a quick trick to help you remember the difference between when you have a positive x squared term versus a negative x squared term. The positive will yield a parabola that goes upward. A negative will yield a parabola that's going to go downward. Let's take a look at another problem here. Take a look at one more and see how this graphs. We're going to look now at question number 20. And in question 20, let's go ahead and move this up now. Make sure that this is in full view of the camera. And indeed it is. We're going to have the function g of x is equal to 1/4 x squared. So we have g of x is equal to 1/4 x squared. So in this function, we're going to go ahead and rewrite this as y equals 1/4 x squared. I'll label this x. I'll label this y. We're going to go ahead and make a table below here. This, at the bottom here, we have a little more room to write all this out. So here I'm going to put x. I'm going to put 1/4 x squared here. I'm going to put y here, and then my ordered pairs x, y that we're going to put on graph paper. Now for this one, I'm going to choose my points a little more wisely. I do want to try to produce examples that I'm going to be able to graph all this pretty quick. So let's take a look at what those values are going to be. So I'm going to pick values of 0. And let's go ahead and let's pick 4, 8, -4, and then -8. So I'm picking these a little out of order. And what I'm trying to do is I'm going to pick values so that when I square them, actually I don't need to pick those. I can go ahead and pick for this. Let me go ahead and pick 2. And let me go ahead and pick -2. So I'm going to pick these values, and I'll show you why these are going to make more sense in a moment. I want to try to pick values that are going to work nicely with this 1/4 here. So we have 1/4 times 0 squared, 1/4 times 4 squared, 1/4 times 2 squared, 1/4 times -4 squared, then 1/4 times -2 squared. So a little bit out of order, but let's see what happens with these. So this is going to be my y values. This will be 0, 0, 0. 4 squared is 16. 1/4 of 16 is going to be 4. So I have the point 4, 4 here. 2 squared is going to be 4. So 1/4 of 4 is going to be 1. So I have the point 2, 1 here. -4 squared is going to be 16. 16 times a fourth of that will be 4. So I have the point -4, 4 here. Then -2 squared is going to be +4. 1/4 of 4 will be 1. So I have the point now -2, 1 here. So let's see how these points plot out. I have the point -4, 4. I have the point -2, 1. I have the point 0, 0. I have the point 2, 1. And then I have the point 4, 4. So what you see here is, let's first consider the following. We have positive 1/4. It's positive, we know, because it makes a smiley face or it opens upward, unlike the one we saw before, the last one we're working on, which is opening downward. Another characteristic, we also notice that this parabola is significantly wider than the original problem we had. We talked about in the last problem that having a whole number here made this parabola much narrower than this parabola. Well, having a value not greater than 1, but having a value that's less than 1 will make the parabola significantly wider. And as you have the opportunity to work with the graphs of more parabolas, these are going to be some basic characteristics that you're going to have the opportunity to view. So as we work with these a little more, you will have an opportunity to work a little more with tables, but we're also going to learn some quick shortcuts for graphing these parabolas. But then we're also going to have to identify some characteristics of the parabola as well, which is going to be coming up. So we're going to make an some tables with some more examples here, but we're going to begin to identify other characteristics of the parabola. More to come.